Welcome to this lesson in the Designing VMware Infrastructure training course. In this lesson, we'll be talking about understanding vSphere design terminology. In this lesson, we'll first start out by discussing the need for design terminology. Why is it important that we define a common set of terms, and what are those terms? We'll then go into an in-depth discussion of the four major terms that we're going to be using throughout this course, and those terms are requirements, risks, assumptions, and constraints. And I'll discuss each of these in great detail. We'll wrap up the lesson by talking about how all these items fit together in the context of vSphere design. You might be wondering, why do I have to learn new terminology? Why is it important that we set forth a consistent and standard set of terms that we can use throughout this course? An essential part of learning a new language is learning a new vocabulary. For example, I'm currently trying to learn German. And as part of that process, I have to learn German vocabulary. I have to learn what is the German word for car, or what is the German word for bike, or what is the German word for house. In some respects, learning vSphere design is a little like learning a new language, and that means that you have to learn the vocabulary. vSphere architects have a slightly different set of skills than vSphere administrators. What this means for you is that they also have a slightly different vocabulary. So before we get any deeper into this course, let's take a look at some of the key terms that you need to know. Some of the key terms that you really should know as we move through this course are listed here. We have four key terms: requirement, risk, assumption, and constraint. These are all generically referred to as design factors because they influence the design. Each of these influences the design in a different way, and as we move through this section, I'm going to describe each of these four areas, each of these four design factors in greater detail. And here is the first term that we want to discuss: requirements. As you saw in the earlier definition, a requirement is a mandatory condition that you have to satisfy in the design. The very use of the word requirement indicates that this is required. It's something that you must satisfy. Requirements fall into two broad categories: functional requirements and non-functional requirements. The impact of each of these broad categories of requirements is different. Functional requirements will shape the function of the design. In other words, what the design must do. Non-functional requirements, on the other hand, will affect or shape how the design goes about accomplishing those functional requirements. And as you'll see later on in this section, non-functional requirements can also be considered constraints because they constrain the options the vSphere architect has in satisfying the requirements. With that in mind, let's take a look at a couple of example requirements. Our first example requirement is a functional requirement, and it states, quite simply, the design must be capable of supporting additional growth in the environment. While this is a perfectly valid functional requirement, it is also vague. For example, it doesn't say what kind of growth, it doesn't say how much growth, and it doesn't specify over what period of time. 1 year, 2 years, 10 years? Because the answers to those questions that aren't answered by this requirement will impact the design, it's important that you don't leave questions open in the requirements. In a later lesson in this course, we're going to talk about how to define requirements, and I'll provide some guidelines on writing and defining your requirements. But for now, let's take a look at a better version of this same functional requirement. A rewritten version of the earlier functional requirement would look something like this: the design must provide sufficient capacity to handle current workloads and account for 20% growth in the number of workloads over the next year. Boiled down, this says the design has to accommodate for future growth, but what it does is it closes the gaps, it closes the loopholes. It specifies what kind of growth, how much growth, and over what time period. This makes it a more specific and therefore more useful requirement in helping to shape your vSphere design. Now let's look at a non-functional requirement. This non-functional requirement says the design must leverage the company's existing investment in HP ProLiant blade servers. You can see that this sort of requirement, this sort of non-functional requirement, doesn't specify something that the design has to do. Rather, it specifies how the design goes about accomplishing what it must do. And that's what makes it similar to a constraint, as you'll see later on in this lesson. As we wrap up our discussion of requirements, it's important to understand that requirements can and will originate from a number of different sources. There are listed here 4 different potential sources for requirements. For example, applications may present requirements that help you define what a virtual machine should look like, how much memory, how much CPU, how much storage. It might help you shape the logical storage design by providing information on how many IOPS or how many terabytes of storage are required. The business itself, the business of your customer or your own organization, is also a prime source of requirements. Typical requirements that come from a business might include things like uptime or specific growth requirements, such as the example functional requirement I presented to you earlier. You might see operations presenting requirements. Operational requirements might be something like the backups have to be conducted by a specific group, like the storage group, or the vSphere environment should support role-based access control for multiple operational groups. These are both examples of requirements that might come from an operations perspective. And you might also find that there are technological or solutions-oriented requirements. For example, a particular array in the environment might require certain connectivity or present certain limits on what it can do or not do. It's also valid to note that some of the technological or solutions-oriented requirements may not become apparent until later on in the course, as you begin to map your logical design onto your physical design. And this is again where it's important that we take this holistic view, understanding how things are intimately interconnected and understanding the impact of one area on another. Now let's move on to our second major design factor, risks. As defined here, a risk is anything that can potentially prevent the design from satisfying the requirements. Now, your job as a vSphere architect, once you identify these risks, is to minimize and mitigate the risks in the design. Much like requirements, risks can come from a variety of different sources and can take different forms. You might have technological risks, such as a certain technology or product or solution that's present in the environment or the design might not be able to meet the functional or non-functional requirements. You might have operational risks. For example, implementing vSphere in an organization or with a customer might create new processes, introduce new products, or new procedures that the staff or the organization don't know how to handle. There might also be financial risks. As we know, most every organization and customer is going to have a financial constraint, a budget that they have to follow in the design. Does that budget allow enough room for the design to meet the requirements? If not, then you have a financial risk. Let's take a look at a few examples of some risks. Here's an example operational risk. The existing staff does not have the necessary skills or experience to manage a vSphere environment. This should be very common in organizations that are new to virtualization. Perhaps they're adopting vSphere for the very first time, and their staff don't have the knowledge on how vSphere works, how to use vCenter Server, how to use vCenter Update Manager, how to use ESXi, or the vSphere Management Assistant. So your job as the architect is to identify that that is a potential risk, and then in the design provide potential ways that that risk can be minimized or mitigated. Here's another example risk. This one is technology-based. The existing storage array does not have sufficient capacity to meet the projected growth requirements. Now, looking at this risk, do you see any potential problems here? If you answered that the risk is kind of vague, you're doing great. That's right, this risk is a little vague. Remember that the earlier requirement that we listed, the very first example that I gave you, was also vague. In the same way, this risk doesn't identify what sort of capacity it's not able to meet. Is this a storage capacity in terms of gigabytes or terabytes? Is it a throughput capacity? Is it an IOPS capacity? And it also doesn't specify what the projected growth requirements are. So a better risk would be to actually rewrite this and be very specific about what limitation this storage array presents and what type of capacity it's presenting as a risk, what kind of limit it's presenting as a risk. The third design factor that I want to discuss is an assumption. An assumption is some aspect of the design that is accepted as fact but isn't backed by a requirement or a constraint. Now, you might at first have a hard time understanding where assumptions fall into this overall structure of design factors. They are different from requirements, and one of the key ways to determine that something is a requirement versus an assumption, aside from the wording as you'll see in the examples, is the source of that assumption or requirement. Requirements will typically come from outside the architect, the customer or the business that's driving this design. Assumptions, on the other hand, will typically come from the vSphere architect. They are provided by the architect in response to some section of the design that doesn't have a firm enough framework in requirements. And assumptions influence or affect the design by including, excluding, or modifying portions of the design or by modifying other design factors. With that in mind, let's take a look at a couple assumptions that might help clarify things for you. Our first example assumption says, this design assumes the environment will grow by approximately 20% during the first year after implementation. You might see something like this sort of assumption when the requirements given to you by the business or the organization or the customer simply say the design has to accommodate for future growth, like the vague functional requirement that I first presented to you. And if the business or the customer isn't able to tell you how much growth or over what period of time, then you need to fill in that vagueness. You need to answer the questions that that requirement creates with an assumption, because the design has to have something to work within. It has to have some sort of framework in which to work. You can't simply leave something open-ended and say you have to accommodate future growth when we don't know what kind of growth or over what period of time or how much. So we have to backfill those empty areas with an assumption. That's why, again, we did talk about requirements coming from outside the architect, but assumptions coming from the architect directly. Let's take a look at another assumption. It is assumed the customer will reuse their existing monitoring and management solution in the new vSphere environment. In this case, this assumption excludes an entire portion of the design. It says we're not going to talk about monitoring and management in this design because we're going to assume the customer is going to reuse their existing monitoring and management solution. If you were to present a design to a customer or to your own organization that didn't specify how they were going to monitor and manage this environment, then the design would be considered incomplete unless you excluded that portion of the design with an assumption. The last design factor we're going to discuss is a constraint. A constraint is very, very similar, might even be considered identical, to a non-functional requirement in that it restricts the vSphere's architects in satisfying the requirements. It controls or constrains the options that you have as a vSphere architect in how you go about satisfying the functional requirements. Now, like requirements, like risks, constraints can come in many different forms. There may be technological constraints. Only certain vendors or certain technologies can be used, or a specific solution has to be included in the design. Perhaps a specific solution that has to be included in the design also then has a ripple effect and requires that other solutions have to also be included. Maybe a particular storage array has to be used within the design, and that means that only certain storage protocols can be used to access that array. There may be operational constraints. These are similar. I gave you an example earlier when we were discussing requirements about how there might be an operational constraint that says a particular group or department within his organization has to be responsible for taking care of this task. Backups have to be done by storage. Networking has to be done by networking. The networking team has to have end-to-end control and visibility of the networking layer. These aren't functional requirements. These are non-functional requirements. These are constraints that restrict how you go about fulfilling the requirements. There are also, of course, financial constraints, and I mentioned this under risks because typically every customer, every organization is going to have a finite budget. Let's be honest, if there were not a finite budget, if money were infinite, we wouldn't really need to go through this process because we could just put in anything and everything we wanted. But the reality is that there are financial constraints, and this is something that will influence the design because you have to adhere to the constraints. Here's our example constraint. It simply says, Cisco will be the chosen vendor for all networking equipment. You can see that this does not affect the function of the design. It doesn't specify what the design has to do. It simply controls how you go about doing that design by saying that when you select networking equipment, you have to choose from Cisco. Now that I've discussed the 4 design factors, requirements, risks, assumptions, and constraints, let's take a look at how all these fit together in the context of vSphere design. Each of these items influences the design in a very specific way and in very different ways. As an architect, in order for you to maintain the holistic view of the design, you have to understand the impact of these items on the design and, where necessary, account for that impact. A great way to look at this is listed here on the screen. You have to understand the design must satisfy the requirements. If you're given requirements, your design has to satisfy them. Your design has to minimize and mitigate risk. Before you can minimize and mitigate risk, you have to identify risk. Where the requirements are unclear, then we have to backfill those unclear areas with assumptions. So your design has to clearly identify and clearly lay out the assumptions that you're using in driving this design. And finally, design has to adhere to the constraints. If it's a financial constraint, your design must adhere to it. Understanding and accounting for these design factors is a recurring theme we're going to discuss throughout this course. It's a critical part of maintaining the holistic view of understanding the interrelationships and the intricate dependencies that every aspect of the design has on every other aspect of the design. In this lesson then, we first started out by discussing the need for design terminology, why it's important to discuss design terminology, and the role that it plays in preparing ourselves for vSphere design. We then launched into a discussion of requirements and their role in creating vSphere designs. We talked about risks, we discussed assumptions, and we reviewed constraints. And we wrapped up this lesson by seeing how all these pieces fit together within the context of vSphere design. This rounds out this lesson in Designing VMware Infrastructure video training series. Thanks for watching.